let's say that you have a city, and its population in the year 2005 is 15,000, and the population of the city is growing at a steady 400 per year. Let's interpret that in terms of a graph of population versus the number of years. Okay, first of all, we'll count our years starting in 2005. And let's let n be the number of years and p the population. So we have a graph of p versus n. Okay? N is the number of years since 2005. And I could actually, if I knew where my chalk was, number of years since 2005. Okay? Well, our first bit of information is that in 2005 the population's 15,000. So how many years has it been since 2005 in 2005? Well, it is 2005, it's been 0 years. So we say the population in year 0, this is function notation, population in year 0, p of 0, is 15,000. Now, if p of 0 equals 15,000 on a graph of p versus n, that's going to give us the point where n is 0 and p is 15,000. So n is 0 here, 15,000 might be here on the p-axis. So here's a point on our graph that corresponds to our given information. Now, if we also note the population grows at 400 per year, that's the rate of change of the population. More properly, it's the rate of change of the population with respect to time, but your text uses the abbreviated statement. I will too, but I'll mention the longer statement. Okay, rate of change of population is 400. Now, what do we know about rate of change? Well, rate of change is identified with the slope. The slope is the rate of change, meaning then that this graph has to have a slope of 400. So what do we have? We have a point and we have a slope. Point is 0, 1500, slope is 400. So we can abstract that down here. And we can do this from the picture, or we can do it from a formula. The formula is y minus y1 equals m times x minus x1, but in this case, instead of y, we're using p. So it'll be p minus p1, where p1 is the p coordinate of this point that we know. And then that's m times x minus x1, but we're not using x, we're using n, so we're going to call that m times n minus n1. Then we can write everything out. P1 is 15,000, N1 is 0, because P1 and N1 are the coordinates of our known point. N equals 0, P equals 15,000. And our slope is our rate of change, that's 400, and then we can solve for P. And we get P equals 400N plus 15. Alternatively, we can just draw our fundamental triangle, okay, for the point that we know, 0, 15,000, and a line of slope 400, because that is our slope, that's our rate of change. And the arbitrary point out here, it's no longer xy for the same reason over here, it's np, because we're using n instead of x, we're using p instead of y. So this point is np, the rise is p minus 15,000, p minus 15,000, the run is n, well it's n minus 0, which is just n, so we could say it's n minus 0, which is just n. So our slope is rise divided by run, p minus 15,000 divided by n, and our slope is 400. So we set this equal to this and solve for p. We're going to get the same thing. We're going to multiply both sides by n, that'll give us 400n, and then we're going to add 15,000 to both sides, that'll give us our plus 15,000. At this point, we can ask all kinds of questions. We could ask, for example, when is the population 20,000? Okay? Well, that means using, there it is, using this equation, well, T is 400N plus 15,000. So we solve the equation. 20,000, that's the population we want to get, equals 400N plus 15,000. We solve this for N. N is the number of years. It tells us how many years are going to pass before the population reaches 20,000. Very easy to solve. Subtract 15,000 from both sides, divide both sides by 400. We get N equals 5,000 over 400, which is going to equal 12.5. Means 12.5 years will pass before the population reaches 20,000. Now, we could, given the original information, we don't have to set up a linear equation. We don't have to solve a linear equation. If we want to know how long it takes to get to 20,000, we can just say, well, we add 5,000 at 400 per year, so let's divide 5,000 by 400 to get the number of years. Okay, we can do that, but that's not what we're going to do. We're going to learn to set up equations and functions and use them to answer questions. There's much more that can be done with this function, and many more questions that could be answered that can't be answered quite as easily by just figuring it out. Okay, so this is the way we're going to use linear functions.